The trick is to figure out which ions the salt breaks into and whether each of those ions is acidic or basic. For example, will ammonium sulfate be acidic, basic, or neutral when it's in solution? Well, when this breaks up in solution, it makes two NH4 plus ions, and it makes an SO4 2 minus ion. Notice that I broke it up into its constituent ions. Now consider each of these ions separately. NH4 plus is acidic because it can donate a proton. In fact, NH4 plus reacts with water to make H3O plus and ammonia. That's a legit equilibrium that happens. You may also want to just consider it as ammonium simply breaking up into a proton and ammonia, but either of these is okay. In either case, the NH4 plus is given up a proton. That makes it acidic. This here is basic because it can accept a proton. See? SO4 2 minus can accept a proton to make HSO4 minus. The trick, though, is that that doesn't happen. In fact, H2SO4 is a strong acid. That first proton comes off, 100%. The second proton comes off, almost 100%. This is a strong acid, and this is its conjugate base. It is a weak conjugate base, though, because it's the conjugate of a really, really strong acid. This hardly affects the pH at all because it's so weak, whereas this can just give up protons. That means that when you put this in solution, you're going to form an acidic solution. This will give up protons, but this does not accept or suck up protons. So you're going to have a net addition of protons to your solution. Let's try this again. When you dissolve Na2SO3 in solution, what do you get? Well, you get two Na plus ions, and you get an SO3 2 minus ion. What are these the conjugates of? Well, this is the conjugate of NaOH, a strong base. That means this is weak and probably won't affect the pH of your solution. This is the conjugate of H2SO3, which is a weak acid. That means that this has the ability to suck up protons. It is not the conjugate of something that is strong. It is the conjugate of something that is weak, and so it can literally accept protons. SO3 2 minus can take a proton and suck it up into HSO3 minus. The reason you know that can happen is because H2SO3 is a weak acid, so its conjugate may be strong. We can do the same for this. NH4CN breaks up into NH4 plus and Cn minus. Will either of these affect pH? Well, this certainly does. We already saw it can give away protons. This is the conjugate of HCN, which is a weak acid, and so this has the ability to suck up protons. That means when you dissolve this into solution, this ion starts giving away protons. This ion starts sucking up protons. Which one wins? You have to look at the Ka of this and the Kb of this to see which one wins out. The Ka, or proton donating ability of this, turns out to be 5.8 times 10 to the minus 10. The Kb of this, or proton sucking up ability, turns out to be 1.6 times 10 to the minus 5. That's the bigger number between the two. The proton sucking up ability of this ion beats the proton donating ability of this, and overall this solution would be basic. Cool? So, if you're ever trying to figure out what the pH of a salt solution is, break it up into the ions and see how each of the ions affects the pH of your solution.